Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Hasan Savran. Hey, Hasan, how are you?
Great, thank you, Robert. You?
Thanks for joining the show. Hasan is the author of the Cosmo DB SQL Studio extension for Visual Studio Code, and we thought we'd take a look at that today. We think that, obviously a lot of Visual Studio users also use Visual Studio Code, and so we like to include some Visual Studio Code in the show from time to time. And Hasan reached out and said, hey, I wrote this cool extension. Can I come on the show? And we said, yeah, we'd love to have you. So tell us a little bit about yourself, and then tell us about the extension and why you wrote it, and then let's see it in action.
Sure. Thank you, Robert. Thank you for having me again. Well, my name is Hasan Savran, and I'm from Cleveland, Ohio, United States. And I'm a data platform MVP. This is my 5th year, and I'm proud and honored to be part of the program. Well, when it comes to the extension, I'm pretty familiar with the Cosmos DB. So I was playing with it, so I have many talks you might see online. So Cosmos DB is very developer-friendly database, and if you want to do things, you need to kind of write a code to actually be able to see, for example, execution metrics or indexing policies. In my talks, I wanted to have like a central application. I guess if you compare to SQL Server, you have the SSMS out there. You can do everything from there. You can give demos. So the Azure Cosmos DB did not have a central place like that. So I say, well, why don't I create one? So that's how I actually started with this extension.
Excellent. Let's see what it looks like.
Yeah. So I'm going to actually show you how it works. The first box which I didn't show you here, but all we are going to do here is Control-Shift-P. And if you actually write the Cosmos DB SQL Studio, that will be the first one comes up. It is going to ask you how to connect, and you're just going to put your connection string in it. And after that, you are going to actually see this page. If you don't have the Cosmos DB SQL Studio yet, you can go to extensions here and search for the Cosmos DB SQL Studio, and you can just install it directly from the VS Code, or you can go to Marketplace and download it from there manually if you like.
Great.
So I put my connection string I got from the Azure portal, and the first thing you're going to see here, this is going to list all the databases under your database account. So I'm just going to I put the Stack Overflow data here so we can kind of see how it works. Under the database, as soon as you select it, it's going to actually display all the containers, available containers here. So I'm just going to pick one here. So I guess that's the first thing, and usually I talk about in my sessions is when you pick here, well, as you know, Cosmos DB is a distributed database. That means that your data is all over the place, and you might have multiple partitions, physical partitions. By clicking this button here, actually, this is going to give you how many physical partitions you have under this container. So, if you are in Azure portal, you might need to kind of go and create like a report or, some stats to kind of see that. So you might need to kind of jump in from links to links. In here, you can easily see how many partitions actually this container has by just clicking one button here.
Cool.
So rather than that, so what else we can do here? Let's actually type a simple query here. Let's say select 10 from C. So we should get 10 records when we execute that. If this is the first time you are seeing Cosmos DB, you might guess what is C. Well, C is the posts, because that is what we actually selected right now. So you can name that whatever you like. Mostly we just say C.
Okay.
So you can click the execute button, and we should see 10 items. As you can see, we got 10 records, top 10. So there are some, good information here you can use. Probably the most important one, how much this actually cost me, right? So in Cosmos DB, everything is by request charge, and this cost me 12.90 request units. Now you might say that, well, that's kind of
a lot. Is that a little?
Isn't it? You might say that's a lot. Usually a query kind of costs you, if it's like a simple query, minimum 2.5 or kind of like a 3 request units. So this is kind of a lot because I'm getting only 10 records here. But in Cosmos DB, in a distributed system, usually you have the shard key or the partition key in Cosmos DB. As you can see, I don't have a partition key here. That means I am actually running this query in every partition that I have. So if you want to kind of look at the details, you can go under the execution metrics here, and you can see that there is 5 requests, not 1, but there are 5 requests. And you can click here and see that how much each partition is actually costing me. So each partition is actually sending me 10 records. You might see 10, but it looks like I'm getting 50 records because I'm not giving a partition key or the shard key. An application doesn't know which physical partition I'm going to get it from, so it gets 10 records from each physical partitions. So that kind of, gives you kind of like an idea of what's going on in the backend when you deal with the Cosmos DB or any kind of distributed databases. There are some information, you can use here under the execution metrics. Most of them is like in milliseconds, and you can use them if something is going wrong. You might be able to use this tab to figure out what's really happening in the backend. So this is pretty useful.
Yeah.
Some of this information is available in Azure Portal. You can kind of maybe see some of them. But if you want to see all of them, you kind of need to write your own C# code or whatever SDK you are using to be able to kind of see all these items.
And it's also nice not to have to do the context switch of switching out of your VS Code where you're building an app and head over to Azure, log into the portal.
All right. So this really kind of, helps a lot, especially, if you are not a developer, especially if you're a DBA, you try to learn and you don't know any kind of coding, well, you're kind of stuck. So this application really kind of helps them to see what's really happening in the backend without, learning any kind of programming code. So rather than what else we can do here is we have another option here, indexing policy. In Azure Cosmos DB, just like any other databases, you need to worry about the indexes. And you can actually come here and see what kind of indexes you have in selected container. So we have the posts container. It looks like there are some properties are excluded, which means that, those are not indexed. And there's all kind of other different, indexes here. I'm not going to really talk about them, but, it gives all the information that you need. If you are having kind of performance issues, you can come here and easily kind of see that. So, and also I just actually added the re-indexing progress. This was available only from the Azure portal, and to see the latest percentage, where the re-indexing is, you have to refresh the button again and again. So in here, actually, I put an interval here and checks like every 30 seconds until this actually goes to 100%. So you don't have to kind of go Azure portal and kind of click that button to see where your re-indexing is every time. So that is pretty useful. Now, let's say maybe our query is not this simple. So let's actually try to make this query a little bit more, I guess, complex. So let's say my C, I guess I'm looking for the owner user ID, say 100. And let's run this first. So when we run this, it's still 19.49 because I'm still not having the my partition key here. That's why it's kind of this high, but I'm just using this one to kind of see how we can actually tackle the problems. So as you can see here, I am getting 128 documents. And 128 actually coming from indexes, because you can see that index hit is 128. So everything is indexed. As if you remember, looks like my score is not indexed. So for whatever reason, you are writing, and let's say I'm going to say my C score is larger than, let's say, 100. So if I'm going to execute that, things are going to get a little bit interesting here because now, I'm getting 5 items. But if you look at the index hit documents, it's not 128 anymore because, well, it's 5. So there's something going on here. To kind of tackle stuff like that, I created this query analyzer here. And to start this, you can actually click the start, and it will start to track all the items, what is changing. So for example, if I'm going to go and re-execute this one, it's going to run and it's going to give me all the information I need in here. So as you can see, I got 128 and all is coming from the 128 indexes.
Mm-hmm.
So if I'm going to add the score, and let's see, my query is changing, I'm optimizing my query, and I run the second one, as you can see, I am tracking the performance, how everything is changing. In some items, like in here, for example, I am getting 128, but not all of them is actually coming from the indexes because the score is not indexed. You can easily see in here.
Right.
So what do we do in situations like that? What we can do here is Cosmos DB has an indexing metrics option, which you can come here in options and you can just check this one and you will see a new tab comes up here. Now, if I go in here, now you are going to see that Cosmos DB is actually suggesting me some indexes, and one of them is score. Yeah. And it's saying that, we are using the owner user ID, so please do not touch it. But any of those items here that, Cosmos DB is suggesting might be helpful and make this request charge much cheaper. So I'm not saying go and create them in production as soon as possible. Just, test them in dev, be sure that, they are making some change. In this case, probably it's going to make some change if I index it because it's in my, filter here. So this is a kind of nice one to have if you're like a DBA or if you're a developer, you have some problems with your queries. This can easily, I guess, kind of guide you to the right way, the indexing metrics.
Cool.
Let's see what else we have here. So in the options, I can demo maybe one more item for you here for the max item numbers. So the max item numbers, when we have a transaction to Cosmos DB, what we are really saying, this is the default one, Cosmos DB will return you 100 items. So if your number is less than 100, well, it's going to return that. But if, let's say, if your number is higher than, let's say, 150, that means that we have to actually visit Cosmos DB twice. So that's why this one is kind of important. If you are getting, I guess, if you try to optimize your query, you can easily optimize it by using this one. So let's try to demo how this one works. So I believe this one is the owner user ID. One has a lot of results. So if I run this one, let's see my items. Should be much higher. Okay, now it's 238. And my max item number is 100. So if you actually go here and in our execution metrics, when we open the view here, you see that nothing is larger than 100. So we are visiting each physical partition once. But if I'm going to go here and make my 150, for example.
Mm-hmm.
Now, don't forget, we are visiting right now 5 times the Cosmos DB. If I open this right now without executing it, we will see that we have 1 and 2 larger than 50.
Right.
So what I'm expecting here is I'm going to hit this partition twice, and I'm going to hit this partition twice because I'm requesting 50, not 100 this time.
Yep.
So if I execute that, this 5 view here should go to 7.
Indeed.
As you can see, the maximum number here is 50. So you can use max item to, I guess, optimize your queries depending how much data you are getting from the Cosmos DB.
Cool.
Let's see.
Cool.
And one more option I can actually give you here, which is kind of like a pain in Cosmos DB, is deleting data. Because if you need to delete custom data, you kind of need to write your own code for that. First, you have to select the code, select the data. And to delete the data, you need to know the partition key, and you need to know the ID of the document. So you can easily click this delete button here. And this delete button actually deletes whatever is selected, the last select statement here. and it automatically finds the partition keys and document IDs. And if I click delete here, which I'm not going to do it, but it's going to go and delete them one by one here for me. So that kind of makes life easier for everybody too.
So without the extension, how would you have done these things? What do you need to do to delete? What do you need to do to set these options? The extension makes it really easy. What would you have had to do? What did you have to do before you wrote the extension?
So some of them is available from the Azure portal. You can kind of do some of them. But as I said before, you kind of need to know which icon to click and which page to go. So that can be kind of a little bit pain. Or you have to write your own SDK code. For example, delete. I think this is the only delete place I know that you can actually go and click a button and delete items. If not, you have to kind of almost need to go and write your select statement, then delete them one by one by if you're using C# SDK, by a C# code.
Cool.
So this is the first demo I'm going to give. And the next demo actually I'm going to give you is a little bit more, I guess, maybe exciting because it's about the geospatial data.
Okay.
So for that, I'm going to use a totally different database. So I am going to go and take another VS Code here. This is the same thing I just did. This is the same Cosmos DB SQL Studio. In this case, I have a different database and different container. So when it comes to geospatial data, it can be tricky. So what I have here is I have a couple of containers. One of them just have all the hurricanes that I got free from one of the government websites. So I'm going to go and get all the data for Katrina and execute it. Now you can really see everything here in JSON, no problem. But as you can see, we have a location, which is a geospatial data type, and it matches as a point, and we have the coordinates of the Katrina in whenever that times. So what we can do here, we can easily go and click the map here. Now, for map to work, we kind of need to look at some of the items here in the options. So in the options, as you can see, it says the spatial property to use in filter. It says geometry. I'm going to change this to location. Because if you look at my results, my data is under the location. So you kind of need to give the JSON path for this thing to work. Now, in my options, it's under location. If I go back to map now, and if I execute this again, we should be able to see let's see here. All right.
Oh,
now,
there we go.
This one gives you, those are the locations of Katrina. You can kind of see here. So I guess that was my mistake here. I didn't change this one. So usually they should match, right? Okay. Because I am displayed. One of them actually uses in the filter, which you can see the C name is Katrina. So I am searching by the location. But I have another one. I am drawing. So when I am drawing, I need to use a location too. So that was my mistake. I put it out there. So this makes difference if I actually go and change my data to counties, for example, and I want to see all the counties under Texas. So let me clear this first. Let me go back to results. If I click, well, just to be safe, let's actually make top 10 here because the spatial data can be larger. So you are going to get all the polygons. So let's do this first. Now, as you can see, we see actually two areas. One of them says fields, and under that we have a geo shape, which has the location of the county. Other one is the geometry, which actually tells me, this one tells me the location. The other one tells me the, let's see, in the geo point, you can see the location of it too, but in the geo shape, we should have a much larger area, as you can see. Those are the polygons. Okay. So that's the shape of that county. So I don't want to make a search by this because that's going to be a very expensive search for me. So what I did is I get every county. I found the center of the county. So when I make a search, I'm going to search for the center. So I can kind of send, for example, give me all the text as polygon, it is much easier to find the points than finding polygons in it, I guess. So it will be much cheaper. So to solve this problem, that's where these two are going to be different. So the first one is going to be the geometry. The second one is going to be the fields and geo shape. That is really my property names for my data model. Now, I can just take this out from here, go back to map, and execute this one. And I execute this one. This is going to get all the counties in Texas, and it is going to display on the map here. This one takes a little bit longer because, as I said before, just one of the county was like almost 1,000. So you can see in here, everything is here. Now, other one, I can easily show you. You can actually search by a polygon too. So you can go here. I want to see under the counties under here. If I do that, application will go and find the data under, under that polygon. So, and it looks like it's magical, but it's not really magical, because if you actually go in the options and if you click this button here, which shows you what actually query I am running. So if I just clear this one and go here and write this again, as you can see, this is the query I sent to Cosmos DB. I am using the st within function. I am looking at the C geometry. This is what I'm saying here. Geometry, use this one because it's just searching the points rather than the polygons. And this is the polygon I just throw here. So this returns top 100. I add the top 100 here just to be safe. You can just change that in here because geospatial data, it can be heavy. You kind of be careful, because if you actually put a real large polygon here, that query might be really, really expensive. So I just try to control that by the top, I guess, the statement.
Cool. That's awesome.
Thank you. Yeah, thank you. So I'm just working on it. I'm trying to find different ways to kind of improve it. So you can follow me on the from the Twitter if you have any options. If you have kind of ideas, I will be happy to kind of hear and add them here.
And then you can download the extension either from the marketplace or inside Visual Studio Code. Is it maintained in GitHub or anything?
Yes, I use the GitHub right now. I'm thinking about actually making it, open source.
Okay.
But I haven't started yet. So I'm thinking about actually making it open source, because I know that UI can get probably a little bit better. I try my best, but yeah, I'm thinking about open source. But as it is right now, it's a private GitHub.
All right, cool. So obviously, if you're using Cosmos DB, this is fantastic. Have you given any thought to making this available in Visual Studio itself, or is you just going to do Visual Studio Code?
I have been thinking about it. I kind of need to study a little bit, and let's see how the Visual Studio's extension is getting developed. Yeah. But really, most of the not the requirements, but I guess the feedback I'm getting, they want to make this available in the Azure Data Studio. Okay. Because in Data Studio, you can easily connect to SQL Server and other places. So people like to see this under the Azure, data, which is a VS Code, framework. Yeah. It should be easy. But
you could, maybe you're writing the application Visual Studio, but you just use Visual Studio Code as and this extension is kind of a lightweight way to tune your queries and see what's going on. So,
yeah.
Well, that's awesome. Thanks so much for coming on.
Yeah, no problem. Anytime. Thank you for having me.
And so we have a follow-up episode to this where you're going to show us how you built this extension.
Correct.
So I hope you guys enjoyed this and hope you stick around for the next one. And we will see you next time on Visual Studio Toolbox.